Okay, good morning students. So today we are going to see about the last technique, that is chromatography. Okay, the last class, that is before 1 week, we studied about some techniques. Do you remember that? Separating funnel, isn't it? Fractional distillation, these are the techniques we have seen already. So this is the continuation of that. Okay, so the last technique, that is chromatography. Okay, what is the technique name? Chromatography. Okay, ma'am. So chromo. See it? Chromo means color. Okay. So mainly this technique is used for separating the colored components. It is used for separating the colored components. Okay. And also it is used for the separation of two or more liquid. It is used for the separation of two or more solids in liquid. So this technique is employed for the separation of two or more solids from liquid. Okay, so chromatography, today we are going to see about what? Chromatography. Chromo means what? Color. Okay, so mainly this technique is used for separating colored components. Okay, and mainly it is employed for the separation of two or more solids in liquids. Okay, if the liquids contains two or more dissolved solids, then by using chromatography technique, we can separate the solids from the liquid. Okay, and before going to chromatography, we want to study two important terms that comes under chromatography. One is adsorption, the next one is absorption. So the two important terms that comes under chromatography, one is absorption, next one is what? Adsorption. Okay, you can see the difference between absorption and absorption. Okay, what is adsorption? Okay, what is adsorption means the substance that concentrated on the surface of the surface. So any substance that concentrated on the other substance, that is called as what? Adsorption. Okay. So what is adsorption? Adsorption is what? Defined as the substance that concentrated on the surface of others. Okay. Certain example for another one is absorption. So adsorption means that is concentrated on the surface. It is concentrated on the surface. Okay. Absorption means it is uniformly distributed. It is uniformly distributed over other substance. It is uniformly distributed over the other substance. See, we can study this adsorption and absorption by seeing an example. That is chopstick. What is the example given? Chopstick. Okay. If we take this chalk piece and dip it in the ink. Okay. If you take the chalk piece and if you dip it in the ink body, means what happen? This chalk piece will absorb this ink, isn't it? So what will happen? Consider this is a chalk piece. So the upper surface of the chalk piece is blue in color. It will be in what color? The ink color, isn't it? Blue in color. But when we break this chalk piece and if we see the inner surface of the chalk piece, the center of the chalk piece, it will be in white in color. It will be in what color? White in color. Okay, because all the components, that is the solid substances that present in the ink solvent, that color of dyes, that present in the ink, only absorb, that is called as adsorption. Only it absorbs, that is concentrated on the surface of the chalk piece. It never enters inside because of the pore size. All the dyes that are get trapped only on the surface of the chalk piece. Whereas the solvent, okay, where the dyes are dissolved, that is called a solvent. In which solvent these dyes are, that solvent, it is uniformly distributed from top to bottom. And also inner surface also the solvent will be distributed, but the solid particles only found on the surface. Okay, so the solid particles that get absorbed on the surface of the chalk piece, whereas the solvent that is absorbed from uniformly from top to bottom of the chalk piece. Okay, that is the difference between what? Adsorption and absorption. Adsorption means it's just occur. Okay, for example, what we can see, this is the wood in which the sponges get adsorbed, which is what? Attached. Okay, only it is concentrated on the surface of the chalk piece. Where if I dip it in the water, what happens? All the solvents that are uniformly distributed from top to bottom, isn't it? The water get absorbed. The sponge will get absorbed the water from top to bottom, isn't it? That is called as absorption. It is called as what? Absorption. Do you understood what is the difference between adsorption and absorption? Adsorption means it is occur only on the surface, concentrated on the only on the surface area. Okay. Whereas absorption means it is uniformly. For example, if you dip this sponge into water, what happens? This sponge will absorb the water from top to bottom. Okay. That is the example for what? Adsorption and absorption. Concentrate only on the surface of the other substance. Here it is uniformly distributed over the other substances. Okay. So chromatography, this technique is employed for what? Separating two or more solids that present in the liquid. Okay. And before seeing this, we should know what is adsorption and absorption. These are the two principles. Okay, what is adsorption and absorption. Okay, and there are several types of chromatography is there. For example, paper chromatography, column chromatography, thin layer chromatography. So much of chromatography techniques are there. TLC means thin layer chromatography, column chromatography, paper chromatography, 3D chromatography, circular chromatography. So many types of chromatography is there. Based on the solids we will select it. Okay. But for our chapter, what they have given is paper chromatography. Okay. So in paper chromatography we are going to see briefly. Okay. So different types of chromatography is there. Today we are going to see only the first one, that is paper chromatography. See, this paper chromatography. So what chromatography? Paper chromatography. Okay, ma? In this paper chromatography, what is the principle behind it? Based on the difference in the solubility. Based on the difference in their solubility. Based on the difference in the solubility. What solubility means? The solute in solvent. For example, ink, the dyes that are present in the ink is called a solute, in which these dyes are dissolved. Butanol, ethanol, ether, these are some of the what agents, a solvent, which can be act as what? Solvent. And the dyes that are dissolved in solvent are called as what? Solute. Okay. So two terms are there: solute, solvent. Isn't it? Solute means the substance which we dissolve, in which we are dissolving, that is called as what? Solvent. For example, surf is called as what? Solute. In the bucket of water we are dissolving, that is called as what? Solvent. Isn't it? So solute and solvent. Okay. So the difference in the solubility, that solute that we dissolve in the solvent, based on the dissolving power, they will be get separated on the paper chromatography. So paper chromatography works on the principles of difference in their solubility. The solids, two or more solids, on what basis they have dissolved in that solvent, based on that they will be separated on the paper chromatography. So for the paper chromatography, the stationary phase is paper. Since it's a paper chromatography, we are taking what? Paper. There are different types of paper. Normal filter paper is not used. Wattman number filter paper. Mostly we will use Wattman number 1 filter paper. So the paper used for this technique is normally Wattman number 1 filter paper. Okay. So stationary phase, that is stationary means it never moves, isn't it? The stationary phase used for paper chromatography is paper. What type of paper we are using? Wattman number 1 filter paper. And the mobile phase. Mobile phase means what? Moving phase, isn't it? The mobile phase is solvent, suitable solvent. Ethanol, N-butanol, ether or anything that is suitable solvent we should use. So two phases are there for paper chromatography. One is stationary phase, that is the paper. The next one is what? Mobile phase. Okay. Today we are going to separate ink, that is the dyes that are present in the ink, from the solvent. We are going to separate the different types of dyes that are present in the ink. Okay, now we can see the diagrammatic representation. Okay, so once more I am repeating the same. That is, we are going now we are seeing about what? Paper chromatography. In this paper chromatography, how the solid substances are separated in the paper means based in their difference in their solubility. That is, it has solute and solvent. How the solute gets dissolved in the solvent, based on the difference, we will separate the different types of solids. So here two phases are there. One is stationary phase, next one is mobile phase. Stationary phase, normally this is a paper chromatography. We have used paper. What type of paper means? Wattman number 1 filter paper. And the mobile phase is a suitable solvent which carries this solid substances and gets separated. Okay. So suitable solvent is considered as what? Mobile phase, and paper is considered as stationary phase. Now we can see the diagrammatic representative of paper chromatography. So first we can take a beaker. Okay, cut a filter paper, Wattman number filter paper. Okay, cut the based on our requirement or based on the size of the sample, you cut the filter paper, and from the down draw a pencil line, little above we draw a pencil line, and now we are spotting a drop of ink on this paper. Okay, we are spotting a drop of ink using needle. We are spotting a drop of ink on the wall. This few line inches or few inches above. Okay, from the down few inches above we have draw a pencil line. In the pencil line we have keep a drop of what? Ink. Okay, and this beaker has been filled. Beaker has been filled with salt. That is the mobile phase. A suitable solvent like ethanol, ether or anything. Okay. Then take this paper, this chromatographic paper, and insert it. Keep inside this beaker. Okay. Fold it, or just you dip it inside this. And this pencil line, it should be above. It should not be immersed inside the solvent. It should be above the what? The solvent. Okay. Here is our ink spot. Then close the beaker with lid. Okay. So we have cut the chromatographic paper, and few inches above we have drawn a pencil line. Then we have kept a drop of ink, and this paper is transferred to a beaker that containing suitable solvent, and the solvent is act as what phase? Mobile phase. Okay, and close the beaker with the lid. Okay, and leave it for a few minutes. Leave it for a few minutes. What happened is this filter paper start to absorption. Isn't it? We studied, isn't it? What is that? Absorption. That is, it is uniformly distributed over the other substance. So what happened? This mobile phase, it moves upwards. Okay, it moves upwards, and this mobile phase, that is solvent is a mobile phase, so it moves upwards. So slowly this filter paper absorbs this solvent and it transferred from down to top. When the solvent reaches the other end, remove the paper from the beaker. Remove the paper from the beaker. Can you able to follow what we did? We kept the paper inside and we close it and keep it for few minutes, isn't it? For the absorption of solvent on the filter paper. Now the filter paper absorbed all the solvent. Since it is a mobile phase, it moves upwards. And when it reaches the other end, before it is coming to the corner, we have to remove this paper. Okay. And you can see here, okay, different types of dyes. Here we have 3 different spots. When you take the paper, before chromatography, the spot is here. When the solvent moves upwards, it carries the components, that is solids that present in the ink, and they get what? Separated based on the solubility. Based on their solubility and based on the size, they will be get separated on the filter paper. For example, we can see the solvent, the ink move upwards. The ink move upwards along with the solvent. Along with the solvent, the ink spot also move upwards, and you can see different colors that get. See, we can see 3 different spots that appear on the paper. Okay. After this technique, this paper is called as chromatograph. It is called as chromatogram. This chromatograph paper, okay, when we dry this paper, air dry, when we dry this paper, we can see 3 different colors or 3 different types of dyes that is adsorbed on the paper. That is adsorbed. Adsorbed means what? Adsorbed means what? It is stick into the, or it is occurring on the filter paper. Okay, so 3 types of dyes that is get absorbed on the filter paper based on their pore size and their solubility with the solvent. So we have separated 3 different types of dyes from the one liquid substance, that is from the ink. Do you understood? This is called as what? Paper chromatography. Like the column chromatography is also there. In so many adsorbing agents are we can use charcoal, charcoal. So TLC, thin layer chromatography is done with silica gel. These all are used as what? Absorbing agents. Okay, absorbent agents. Charcoal, silica gel can be also used as what? Adsorbents, in which the components are get adsorbed to charcoal and silica gel based on their solubility. Okay, other than this paper, we can also use charcoal, silica gel for the separation of components. Column chromatography means what will happen? Column chromatography, like a burette. There will be a column, like a burette. There will be a column, and this is fully filled. Upper there is a cotton wool, and down there will be cotton wool. In between they will fill it with charcoal or silica gel. Like this we can what? By column chromatography we can separate chlorophyll pigments from the plants. Chlorophyll A, B, C is there. No, chlorophyll pigments are there. Carotenoids are there. So these colored components can be separated by using what? Chromatography technique. When we add solvent, suitable solvent should be added. The sample should be loaded here. Okay. For example, plant pigments means we have to load the plant pigments here, and slowly we have to pour the solvent. So solvent is a mobile force. It comes uniformly distributed. So when along with this, our plant pigment also travel based on their pore size and their solubility. They will be get separated. Different types of colors of pigments will be get separated. Okay. So this is done with the paper and this is done with the silica gel. Okay. This is the paper chromatography or column chromatography. So it is mainly used for the separation of 2 or more solids that present in the liquid. See here, 2 or more dyes, solid dyes that will get dissolved in the ink have been separated, and after the process has been done, it is called as what? Chromatography. So, similarly, you can, with the help of this paper chromatography, you can also separate amino acids. You can also separate what? Amino acids from the samples. Okay, ma'am? Have we clear? Okay, 2 important questions is there. One is adsorption. Next, what is absorption? Okay. Next, we can see about solution. Okay. So, with this, we have completed all the separation techniques. The next topic, okay, is solution. The next topic is what? Solution. So, with the chromatography technique, we completed all the separation techniques. Now, we are going to the next one, that is solution. Solution. You all know what is solution. What is solution? Already we have seen, isn't it? What is a solution? Okay. The solution, 2 main components are there. Solution contains 2 main components. One is solute. The next one is solvent. When the solute is dissolved in solvent, it forms solution. It forms what? Solution. How the solution is prepared? When solute is get dissolved in the solvent, we form what? Solution. For example, salt. When it is get dissolved in water, it form what type of solution? Salt water solution. Forms what? Salt water solution. So what is solution? When a solute is dissolved in the solvent, it forms what? Solution. And the solution is mostly homogeneous in nature. Solution can be also called as the true solution. Mostly they will be in what nature? Homogeneous. Mostly the solution will be what? Solution is it contains 2 or more components that is uniformly distributed. Hence it can be also called as what? Homogeneous. Okay. So what is solution? When 2 or more substances are uniformly distributed, then they are called a solution, and then it is what type of? Homogeneous. So solution contains solute and solvent. When the solute dissolves in solvent, it forms what? Solution. For example, when salt is dissolved in water, it forms what? Salt water solution. Okay. So how can we define solute? Means any substances, if it is present in lesser amount, by weight, then they are called as what? Solute. If they are present in larger amount by weight, then they are called as what? Solvent. Don't think that solvent means only it is the comprises of liquid. Liquids only solvent. No. Any substance, when you are forming a solution, when you are preparing a solution, in that solution, which component is present in larger quantity, that we can call it as what? Solvent. Which quantity is present in lesser quantity, that we will call it as what? Solute. For example, alloys. See? Alloys, copper and zinc. Okay, for example, we have two alloys are there. One is copper with zinc and the next one is what? Copper with tin. Okay, brass and bronze. Two alloys are there, brass and bronze. You see, here copper only we are using major quantity. We are using what quantity? Major quantity. For example, I am saying if you are taking 70% copper and remaining 30% zinc. Here which is solute? Which is lesser in amount? Zinc. So zinc is called as what? Solute. Which one we have taken in larger quantity? Copper. So copper can be considered as what? Solvent. So solvent means don't think that only it forms liquid. Okay. Any substances in the solution which is in higher percentage, that we will call it as what? Solvent, and lower percentage we will call it as solute. Here see salt. How? For 1 cup of water we will take 1 spoon of salt. The concentration is very less. So it is called as what? Solute. And water concentration is more. So it is called it as what? Salt. Okay, so what is how you have to define the solute? Any substance in the solution that is present in lesser amount by weight, okay, by quantity, okay, by concentration. Then we will call that as what? Solute. Higher percentage of the larger concentration by weight is called as what? Solvent. Also called as what? Solvent. Okay. So have you understood what is solute and solvent? What is solution? Solution is a homogeneous mixture. It consists of one or more substance. See here only two components are there, isn't it? Salt and water. Total this solution, salt water solution contains how many components? 2. So hence this can be also called as binary solution. If your solution is made up of only 2 components, then we can call it as what? Binary solution. Salt in water, then sugar in water. This all comes under what solution? Binary solution. Okay. And there are different types of solutions are there. Next we are going to see the types of solutions. So students, what we are seeing? Solution. Solution means what type of mixture? It is mostly it forms homogeneous mixture of 2 or more substances. And mainly solution contains 2 important components, that's solute and solvent. Okay. Solute means the component present in lesser amount by weight. Solvent means the component present in larger amount by weight. If the solution is prepared of only 2 components, then we call that it is what? Binary solution. Binary solution. See, solute not only one. It may be made up of 2 or more solute particles that can be dissolved in one solvent. Okay, that can be also done. Okay. So next we are going to see about the types of solutions. Mainly 3 types of solutions are there. One is, and this classification, okay, many types of classifications are there based on the size, based on the solvent. So many types of classifications are there. When you go to the 10th standard, you will study briefly about other classification. Here, only one type we are going to see, that is based on the size. Based on the solute size. How? Based on the solutions. How solutions are classified based on the size of the solute. Okay, the solute based on the size of the solute, we can classify this solution into 3 major categories. Okay, ma? See, listen, there are different types of classifications are there. So based on the solvent we can classify. Okay, aqueous solution and non-aqueous solution is there. Next saturation level is there. Saturated, unsaturated, supersaturated is there. This is based on the size of the solute that present in the solvent. Okay, 3 are there. One is true solution. Next one colloidal solution. Next one is suspension. So 3 types of classifications are there based on the size. One, you can form true solution, it can form colloidal solution, it can form suspension. First one is true solution. For example, salt in water. See, the solid particles that get completely dissolved in water, and the size is very small. The nanometer size, it is very small. You cannot see with our naked eye, and at the same time you cannot filter this salt from the water. Can you filter the salt from the water? No, it is not possible. It is impossible because the size of the salt is very small in size. It is nanometer. Okay? Very small in size, 10 to the power minus 7 nanometer maybe down. So it is very less. So it cannot be seen through the naked eye. At the same time, you cannot filter. It is very. So it forms homogeneous solution. It forms what type of solution? Homogeneous. And this true solution is very transparent. It will be clear solution. They take it 3 classes in your home. Okay, what you have to do? Take 3 transparent classes. Okay, 3 classes. One you fill, 3 also you fill it with the same water quantity. One you add salt. The next one you add starch. Starch will be there, isn't it? At home, starch water. Take some starch and add to the water. The last one, wheat flour or sand or wheat flour, anything. You can add it on the third beaker. Okay. So take 3 cups. First you have to add salt. Next one you add starch. Next one you have to add what? Sand, or you can add what? Wheat flour, and see the difference. Okay, here salt completely gets dissolved. Here it forms a translucent. It won't be semi-transparent. It won't be transparent. Cloudy. It looks what? Cloudy. The water looks what? Cloudy. Okay, you can see the particles. You cannot see the particles that is clouding in the liquid. Here, if you see the suspension, the wheat flour slowly they start to get settled down. Isn't it? Sand. If you put soil or sand in the water, what happens? It will get settled down. Isn't it? So it forms suspension. Cloudiness it will be there. That is called as colloid solution. Here true solution. In the true solution you cannot filter. Okay, and it is homogeneous, whereas these two forms heterogeneous. These two are heterogeneous because they are not uniformly distributed. Here only these two solutions get uniformly distributed, and the water look very transparent. Here it is not transparent. It will be very semi-transparent. Okay? Or you can call that as translucent. That nature, isn't it? Take little starch and dissolve in the water and see the cup. That nature, it is just colloid, like a colloid, or just it look a cloudy, and you cannot, it will not be clear solution, just a semi-transparent or translucent. Here it will be opaque. That is both transparent. Half of the glass will be very transparent. The last part, sedimented part will become cloudy. So that you can call it as what? Opaque in nature. Opaque in nature. Okay. And these two, what is that? Colloidal and suspension has two important properties that it too shows Tyndall effect. This colloidal solution has two important properties, that is it exhibits Tyndall effect, and also it shows Brownian movement, and also it shows what movement? Brownian movement. These two properties are only applicable for what type of solution is colloidal solution, where TS, that is true solution, and suspension will not show these two properties. Okay. The next class we will see what is the Tyndall effect and what is the Brownian movement. So students, based on the size of the solute, okay, we have classified the solution into 3 categories: true, colloidal and suspension. True means it is very less than 10 power minus 7. It is 10 power minus 7 to 10 power minus 7. It is greater than that. It is called a suspension. And here, example, salt water, starch water, a sanding water or wheat flour. You can see the difference. Here, the size of the true solution is very, very minute, and it cannot be filtered. It is somewhat large when comparing to the true solution, so it forms colloidal. When comparing to colloidal suspension, the solid particles can be seen through naked eye, and they will get settled down. Okay, and this forms homogeneous. These two forms heterogeneous. Okay, the next one, this is very transparent. It is translucent or semi-transparent. It shows both transparent and translucent. So this is called as what? Opaque in nature. And this colloid, they will exhibit two important properties: Tyndall effect and Brownian movement. The next class we will see what is the Tyndall effect and Brownian movement. Okay, so under the chromatography heading, you can see what is two headings: adsorption and absorption. You learn that two topics. Okay, what is adsorption and absorption. Okay, the next class we will see. Thank you.